In this video, we're going to be talking about conditionals and if statements. Conditionals are expressions that evaluate true or false. So you can think of, if you have two values, let's say 3 and 4. 3 equal to 4, that evaluates to true or false, or yes or no. True is equivalent to yes, no is equivalent to false. In Python and in most programming languages, things that evaluate true or false, we call those booleans. In logic, they're also called booleans, but that's what we'll refer to them as. Here in this table, we have several different operators that we can use to create an expression, to be able to check to see if something is true or false. So we have the double equal sign, and we don't use a single equal sign. The reason why is because a single equal sign is an assignment operator. So you're taking a value and putting into a variable. Remember, whenever we talked about variables, we had like a is equal to 4. So really what that means is that we're assigning the value of 4 into the variable a. If you're wanting to check for if something is equal to each other, if they're equivalent, we use the double equal sign like this. And so we could check to see if A and B are equal to each other or are equivalent by saying A double equals B. And this is going to evaluate true or false. If we want to see if something is not equal, we put the exclamation point in front of the equal sign. So you say A, you could ask a question, is A not equal to B? It's kind of how you could look at this. It is important on which side, which order you put these. You can't say equals in the explanation point. You got to say exclamation point equals. If you put equals exclamation point, you're going to get an error. You're going to get a syntax error. So it has to be, the explanation point has to be to the left of the equal sign. And so this checks to see if A is not equal to B, and that'll evaluate true or false. To check to see for greater than, A is greater than B. Less than sign, A is less than B. No, there should be no surprises there. And then we have the greater than or equal sign. A is greater than or equal to B. And then the less than or equal sign is A is less than or equal to B. Notice that the greater than and less than sign are also on the left side of the equals. So notice this with the not equals and with the greater than or equals and less than or equals, you always put the equal sign on the right. So keep that in mind. Let's look at a few examples. 4 double equals 4. Is 4 equal to 4? That's true. We could also do the following. We can say 4 is 4 equal to 2 plus 2. And this works. The reason why is because this 2 plus 2 gets evaluated first, set equal to 4, and then we check to see if 4 is equal to 4. So technically, this equation and this equation are equivalent. Notice that order is important. Somebody may want to do 4 is 4 equal to 2. And that'd be equal to true or false. Then you'd have false plus 2. Well, that doesn't make any sense. What is the value of false plus 2? That doesn't make a whole lot of sense. So keep that in mind. It's a little bit early. I'm kind of surprised I have this example here this early because I could see how this could cause some issues with students, but I wanted to throw this in there just so that you would see that, how this works. So before the equals or the double equals or the equivalency sign, however you want to call it, is evaluated. You do all the arithmetic on the left or right first to check if something is true or not. A proper way of doing this would be also to put parentheses around this. So you'd have parenthesis 2 plus 2. And that'd probably be a better way of doing it. Also remember that you can try these examples in our little Python environment here, Thoning, or however you pronounce it. I'm going to always pronounce it Thoning until I find some other way. But down here in the shell here, say 4 is equal to 4. That is equal to true. You can say 4 is equal to 2 plus 2. And oops, I made a typo. So it needs to be double equals, and it is equal to true. And see what it says here. I'm glad I did this. It says that this is a syntax error. Syntax error, cannot assign to literal here. Maybe you meant double equals instead of single equals. And what it means, the literal, it just means that this is like a hard-coded value. It's not a variable. What it's expecting here is for, instead of having the 4 there, is that it would be a variable. Like, for example, A is equal to 2 plus 2, and that's valid. And if you look at what the value of A is, it is 4. So this is the best way to kind of learn here, is to try some different examples, see what works and what doesn't work. Maybe you type a mistake like what I did here, where you put a single equals instead of double equals, you get an error, and then try to understand what the error means. And of course, to be honest with you, sometimes the errors are a little bit of gibberish whenever you first start, because programmers wrote the compilers and sometimes they use terminology that's not really useful for beginners, unfortunately. They put something in there that's a little bit more technical, and because they're looking at it as from an abstract abstract area is really the wrong word. I'm really having a hard time thinking of what word I'm wanting to use, but their mindset is very abstract whenever they're writing the compiler. So they're not thinking of a simple example like this, 4 is equal to this, because what it would say is, hey, this is silly. Really what the error should say is, hey, this is silly. You can't assign a value to another number. That's silly. But of course, whenever they're writing the compiler, they're not thinking of it in simple examples like this. They're thinking of it as a more abstract concept. And so their error messages usually are a little bit more abstract. And you've got to get used to that. If you're going to be a programmer, you've got to get used to how the errors, what the errors say and what they mean. So I'm not going to go through all of these examples. I'll let you do that on your own, but just remember you can do that. This is a great way to learn. So please keep that in mind. Remember that in a lecture or two ago, we tried to add a number and a string together. We got an error. And it's because it doesn't know how to perform that operation. With numbers and strings, though, they are not equivalent. So if you do something like this, even though it's valid, what you're going to get is you're always going to get a value of false. So you take any string, you try to see if it's equal to a number, it's always going to come up with false. It doesn't matter even if the value in that string is equivalent to a real number. It doesn't do that. It doesn't do that conversion for you automatically. You have to do that yourself. And if you go back and look at the lecture a few lectures ago where we talked about numbers, I do show you a few examples of how to do that. The not equals also works. And of course, for some reason, I use the exact same example as I have up here. Probably I should have said this is not equal to 3. Let's see what happens whenever we do that, though. Let's say the string 3 is not equal to 3, and that should return true, and it does. So I may change that in the notes. So if you see that that isn't proper, if this doesn't show up in your notes, that's why I've gone back and made a few adjustments to it. On the other hand, if we try to take a string and compare it to a number, as in is a greater than 3, this will produce an error. And the reason for that is because it doesn't know, does a string come before a number? Does the number come before a string? We don't know. So what it's doing is that it's saying, hey, this isn't supported. It just doesn't know how to do this. It doesn't know what this means. And so what it's going to do is produce an error. It knows what this means. It knows that these are not equivalent. So it can come back and say, okay, these aren't equivalent. That's false. But whenever it comes to this, there's some order here. You know, one is greater than the other is what it's asking. And so that implies order. And so since we don't know if a string, you know, a string 3 is equivalent to the number 3, we just output an error. Now, logical operators, we can also, we've talked about expressions, be able to evaluate true or false. To be able to expand on this, we have logical operators. We have and, or, and not. They're shown here. So the and operator, we have a certain expression, and then we can say and then another expression. So we can have several different expressions added on to each other. And remember, what is an expression? It's anything like what we have here that evaluates to true or false. So any of these examples that we've seen before is an expression. And so we can combine these together in such a way that we can create more complex expressions and see if they evaluate to true or false. So if we have A is an expression and B is an expression, we have A and B, where A is false and B is false, the result will also be false. False and false is going to evaluate false. False and true will evaluate to false. And also true and false evaluates to false. The only time that A and B is true is whenever both A and B are true. True and true evaluates to true. So note, keep in mind that both operands must be true for the result to be true. That's an easy way to remember if whenever we're using an and, if the result is true is only if both operands evaluate to true. So let's look at an example. Let's say we have a student must have 65 credits and must not owe the money any college to apply for graduation. Quite often you cannot graduate from a college if you've got, if you still owe them money, they will not give you your certificate or your they won't let you graduate. They won't give you a diploma. So how can we do this? So let's say we have a variable called credits, it's equal to 5, and then balance is also equal to 0. We then can say, we create an expression, credits greater than or equal to 65, because we must have 65 credits or greater. We can have 66, we can have 70, whatever. We got to have at least 65 credits, and our balance has to be 0. Now, what I put here is less than or equal to 0 because maybe there's a balance out there, that you've got a refund or something, and they put it back on your account. Well, of course, they should give you they should let you graduate if your balance is actually positive. So that's why we write this. And there's other examples here. And I'll let you go through those one at a time. I usually create the variables and then I show what the expression would be. And so actually you could type these into Thony if you want. Let's look at the second one and I'll actually do that. For the second one, to pass a class, you must have a grade of 65% or better, and you must have taken the midterm exam as well as the final exam. You can assume that if someone took the midterm or final, their score is greater than 0. So if they get a 0 on the exam and they took the exam, what we're going to do is just make the assumption that if they took the exam, they're going to do better than a 0. Getting a 0 on the final exam is equivalent to not taking the exam. I'm not sure how you would pass a class with grade of 65% or better if you made a 0 on one of those exams. So what we can do is in Thony, let's bring it up here. We actually could say grade equal to 70 in this example. Then we could say midterm is equal to 60 and final is equal to 80. And then we could check, we could create an expression by saying grade is greater than or equal to 65 and midterm is greater than 0 and final is greater than 0. Hit enter, that equals true, and that makes sense. Why? Because if we plug in 70 in here where it says grade 70 is greater than or equal to 65, that evaluates to true. Midterm has a value of 60. 60 is greater than 0. That's also true. And final, which is equal to 80, is greater than 0. Now, another thing that you could do is you could break these up. You could, instead of writing the whole expression like what I did here, you could break these up and say grade greater than or equal to 65. That evaluates to true. Midterm greater than 0. That also evaluates true. And final greater than 0. That also evaluates to true. So that would be true and true and true. And of course, that evaluates to true. Notice how that works there. I'll let you go through example 3 and 4 on your own and try those if you'd like. Another thing that I will try to do is go in here and clean this up a little bit so that this looks a little bit better. Maybe on each line have credit equal to 65, balance is equal to 0, and do all of this. So that way it looks a little better than what I have here. So if in your notes it looks a little different than what I have here, where these are spaced out a little bit more, one per line, that's why I've gone in and made some adjustments to the notes. Now let's move on to the OR operator. We've got the AND. Remember, we just talked about the AND operator. There's also the OR operator. Looks exactly like the AND operator, the syntax, except that we have the OR here in the middle. For the logic of how the truth table for an OR looks like the following. False or false evaluates to false. Otherwise, it evaluates to true. So false or true is going to evaluate to true. True or false evaluates to true. True or true evaluates to true. So an easy way to remember the OR operator is just one operand must be true for the result to be true. So if you have a true anywhere, like here, here, or here, it evaluates to true. So let's look at a few examples of this. You carry an umbrella on days that have at least 50% chance of rain or 50% chance of snow. And I guess you don't carry an umbrella if it's less than that. So let's say rain is equal to 50 Snow is equal to 10, which these are going to represent percents. So we could have rain greater than or equal to 50. Does that evaluate to true? Oops, notice I made a mistake here. I put a space between the greater than sign and the equals. That is a mistake. We can't do that. So notice that they've got to be right up against each other. So whenever we do that, since rain is equal to 50, 50 greater than or equal to 50, that evaluates true. When you have snow greater than or equal to 50, that evaluates to false. So we have rain greater than or equal to 50 or snow greater than or equal to 50. And that evaluates true. The reason why is because this evaluates to true. And so if you look up here in your truth table, bring this back up. We have true or false. We have here true or false is going to evaluate to true. So I won't go through each of these examples. You can go through them yourself to make sure that you understand what's going on. Notice in this example, actually, I'm going to look at example 3. It's a little more complicated, so I want to go over it so that way it helps you to understand what's going on. Back in the 90s, there was a Rascals movie. The He-Man Woman Haters Club requires that a person be male and be between the ages of 3 and 10. So we can check for that. And that was a cute little movie from the 90s. So that's something you could watch. It's a great movie to watch on maybe a weekend, a rainy day, something like that. It's actually a very cute movie. So we can look at a person and we can say that, let's say that their gender is male, and we're going to evaluate it by saying it's equal to M. Of course, you could write male there if you want, but I don't want to type any more than I want to. So we can just say gender is equal to M. Let's create a age variable and let's set it equal to 7. And then we can check to see if the gender is equal to male. Notice that in the description up here, it says that the person must be male. And so the way to do that is say gender is equal to M. And in this case, for a person, they were a male, so that's going to return true. And then we want to check that the age of the person is between 3 and 10. And so for the way for us to do that is we say age is less than or equal to 10, or age is greater than or equal to 3. So whenever we do that, we're going to get a value of true here. Because why? Because since age is equal to 7, 7 is less than or equal to 10, that evaluates true, or age is greater than or equal to 3. And that's true there as well. When we do that, we get the value of true. Let's look at this a little bit more. Let's try something that is outside this window. Let's say 17. Now what happens if we do age is less than or equal to 10, or age is greater than or equal to 3? What happens? What are we going to get? We still get true. Why is that? Now this is an error in this. Whenever I wrote this, I made a mistake. And I just noticed this. That's the reason why I stopped and wanted to look at this a little bit more. This is also true. Why is that? Well, if we look at this, age is equal to 17. Let's break this down. Let's try this age less than or equal to 10. That's false, which is with what we expect. 17 is not less than or equal to 10, but excuse me, if we look at this, age greater than or equal to 3, this evaluates true. Look up here at our truth table. Which one of these does that represent? False or true? It's this one here, and it evaluates true. So what mistake did I make here? What mistake did I make whenever I did this? And for some reason, I do this quite a bit. I notice that I make mistakes like this all the time whenever I write code. You'll find out that you do the same thing, and you just got to write tests to try to figure out like what we did here to find these kind of bugs. What would fix this? Take some time, maybe pause the video and look at this. And I will pause here for a minute so that way you can pause the video. And then I will give you what I think the solution is, and we can verify to see if that's true or false. Or see if it's valid or not. See if what I think the correct statement is will fix this mistake or not. So the way I think we should fix this mistake is by changing the changing the or to an and. So instead of having age, move this up a little bit. Instead of having age less than or equal to 10 or age greater than 3, what we want to do is replace that with an and. Now I've got this in the or section, and I think this is a great example of this. But let's see if I'm right. Age greater than or equal to 3. Whenever we do that, what we get? We get false. And that's what we need, because 17 is not in between 3 and 10. So the correct statement here should be gender is equal to M and age less than or equal to 10 and age greater than or equal to 3. We do that, what do we get? We get false. And why is it false? Because age, in this case, is 17. But now let's change age equal to 7 again, which is in our range between 3 and 10. And let's try this again, which I'm going to copy and paste here. If I do that, in this case, we get true. So the real solution to number 3 is actually this statement here, not the one that's posted in the notes. So I think I'm going to leave this here. And what I will do is I will add a note here saying that this is wrong and maybe explain a little bit about what the real solution is here. So let's move on. What I first thought whenever I wrote the notes was, hey, if you put parentheses here, that'll fix it. Well, no, it doesn't. Actually, what fixes it is this statement here, having all ands and not any ors at all. You may make the same mistake or you may not, but this is a great example. I'm going to go ahead and leave that here because I think that it's a great way to explain or the issue of the and or and why this is the correct solution. And so I'm going to leave that there. Now, the third operator we're going to talk about is the not operator. And the way to say that in Python is not and then the expression. So let's look at the truth table for the not operator, and it's pretty simple. If A is equal to false, not A is true. If A is equal to true, not true, evaluates to false. This is just a Boolean expression that returns the opposite value. So the best way to do a not operator is to first find the value of the expression, should evaluate to true or false, and then take the opposite of that value. So if you end up with not true, it ends up false, or vice versa. So here you have the following: not Netflix is equal to Y, or Hulu is not equal or equal to N. It's going to evaluate depending on what values you have, for if you have Netflix or if you have Hulu. Now, we talked about this briefly a few minutes ago whenever we were talking about like the plus operator. What are the order whenever we have more than one logical operator? If the operators are all the same, like what we had before with the ands, an and operator here, and some operator, we have some expression and some expression and some expression. The operators here are the same. In this case, they are the ands. We just go left to right. We end up with a certain value. But if we have like an and or an or here, we can't just go left to right. We've got to think about what the order of precedence is. And so the order of precedence is first, we take care of the not operators, but we may not be able to take care of the and operators until we take care of some other expressions here. Like what we have here, I go ahead and put parentheses around these. If I don't have the parentheses there, it will actually evaluate this first. And I will leave that as an exercise for you to try what this is, how this evaluates if you have a certain value for Netflix and for Hulu. So for example, if I set Netflix, let's say I have Netflix, but I don't have Hulu. And then you have not Netflix. You can try just saying not Netflix or Hulu. Can't type right. See what you get. See, these aren't the same. This expression and this expression are not the same. The reason why is because we do all this stuff in the middle first, between the parentheses. The parentheses have the highest precedence, and then we take the opposite of that. Where here, we do not Netflix. Oops, we should, oh, I typed it wrong. Still the same, same result, but it evaluates this first. Then it does this. So it does the not, it does this first, does the not of that, then it does or this. So try a few different expressions here, try an and, try putting parentheses around it, round one, try a few different things and see what works and what doesn't work. And if you get a result that you're not expecting, then try to figure out why. So we do the not operator first in this case, and we come up with the value of, let's see, Netflix does equal Y. So this is going to come up with false, or Hulu is equal to N. Since Hulu is N, and this expression is always true, we're always going to end up true here. In this case, it doesn't matter what we do here. Remember that or evaluates are true if one or both of the expressions are true. And so we can just ignore what happens up here. We're always going to end up with true. Since Hulu is equal to N, and you can try that. And so you'll get the same thing in either case. So here we get true, copy and paste this. We're also going to get true. And if you're thinking, okay, why is that? Well, it's because this is true. Why isn't it? Okay, we can just say Hulu equal to N. That always evaluates true. And if you go up here to our or, I went right past it. notice here, this is true if B is equal to true, false or true is equal to true, or true or true evaluates to true. So it doesn't matter if A is false or if A is true, A or B will always evaluate to true because B is always true. Now pause, go back over this video a few times if you need to try to understand what that means. But what it pretty much means is since Hulu is equal to N is always true, doesn't matter what this first expression is. It's always going to evaluate to true. So whenever I say not Netflix, and the way to kind of show that is not Netflix is equal to not Netflix is equal to Y. Netflix is equal to Y is equal to true. Put the not in front of it, you're going to get the opposite of what you had. So since this is equal to true, put the not in front of this, you're going to get the value of false. So we scroll back down here, go through those examples a few times if you need to get an idea of how that works. So after you do the not, you do the ands and the ors. The only time that you don't do it in that order is whenever you've got parentheses, and then you do whatever's inside the parentheses first before you evaluate anything outside of that. So in this example, you've got to evaluate this expression here and replace it with true or false, and then you do whatever's outside here. So not a value true or false is going to give you the opposite of that. So first you do the nots. If there's no parentheses here whatsoever, let's assume we've got what we got up here. Let me pull this back up. Since we have this, we do what's inside the parentheses first, and then we do the not of that, and that'll give us a value of true or false. And this expression, this statement here is really important. I personally like to use parentheses when mixing nots and or ors whenever you've got more than one of those in expressions, so that it is implied what order the operator should be executed. But using parentheses is not required, though. It's up to you to decide if you want to use them or not. Here's some additional exercises here. Feel free to go through those. They're not required, but this will give you an idea if you're writing your additional exercises correctly or not. The best way to think about if statements is think about it like as a fork in the road. So far, all of the programs that we've looked at, pretty much we execute one statement at a time. There's not really anything that changes except maybe values and variables. What if statements allows us to be able to do is to execute some code, or maybe not execute some code based on if certain conditions are true or if they're false. So this kind of allows you to be able to come to like a fork in the road and go to the left or go to the right based on something that's going on in your code. So let's look at the if syntax. The if syntax looks like this. We execute, we look at, we start off with if as the if statement, and then some condition. This is just an expression like what we talked about a few minutes ago. This could be something as simple as like gender equals male, or it could be more complex where we have like and ors or nots, or some combination of all of those. It could be very complex if it needs to, or it could be quite simple. The condition could be complex or simple based on what our program needs to do. When the condition is true, body 1 gets executed, and body 1 is just one or more statements. The else gets executed when the condition or the expression is false. The thing about the else clause of this is that it's optional. We don't necessarily have to have an else. We could just have the if portion of that. So let's look at an example to where we do not have the else part of it. So let's say that you want to write some code that looks at a person's age and will print out the statement, you are eligible to vote if the person's age is at least 18. So this is a if statement that does exactly that. We look to check if age is greater than or equal to 18. And of course, this assumes that an age variable has been created and it contains some value. One of the things that we do is we indent. And usually what we do is we just hit the tab space once, or you could hit the space bar a couple of times. So that way we indent. And by doing that, it allows the Python compiler to know that the code in the indentation is part of a single body of code that we want to execute. So let's look at the if else. In this case, we are going to print out you're eligible to vote if the age is greater than or equal to 18. If the age is not greater than or equal to 18, we print out you are not eligible to vote. Now, you see this where it says true. Actually, that's part of the comment. It should be placed up here to the right of the is. And so it does make things a little bit, makes it a little bit confusing. But this, where it says condition is false, that should be up here as well. We can expand on the if else syntax. There's times that we want several different conditions. We don't just have a single condition. We have several conditions where we'll want to look at if something is true, we want to execute some code. Else, if some other condition is true, execute another body of code, and so on. And you can have as many of these as you'd like, just while it meets this syntax. And of course, the else is still optional, but you can have as many of these else ifs as you like. So let's look at an example to where we want to convert a letter grade to a score to a letter grade. We want to convert a score to a letter grade. So if a score is greater than or equal to 90, we want grade to equal the letter A. If score is greater than 80, we want to, greater than or equal to 80, we want to set the score equal to B. And so what happens here is, as we go through and we execute it, it finds the first expression that's true, and then it evaluates that code, that body underneath it, and then it jumps outside of the if statement. So we'd go down here below the if statement. It won't execute the rest of these. It'll just execute the first one that it finds it's true. Even though you may have, let's say, a score of 95, even though 95 is still greater than 80, because we've executed this bit of code, we don't execute the second one. We just execute the first one that it evaluates as true. So I'll leave it as an exercise for you to copy and paste this into Thony and be able to play around with it a little bit. Now, one of the things that we can do is we don't necessarily have to use the and ors or whatever. We just have to have an expression that returns a value of true or false. Python has a lot of functions, for example, string functions that allows us to return true or false based on if a string meets certain criteria. For example, there is a function called isNumeric, and it will check to see if a string contains a numeric value. If it does, it returns true, else it returns false. So here's an example to where we ask for an age, and this will input. Remember that input will return a string. So even if somebody types in, let's say 25, that is not going to be the number 25. It's going to be a string representing the value of 25. Then in the if statement, we'll check to see if age is actually a numeric value, and we'll print you are a valid age. In other words, somebody entered in a valid age. If this returns true, else it'll print out that it's not a whole number. Now, the isNumeric function, it looks to see if there are a few spaces before or after the number. This would return, isNumeric would return the value of false. To eliminate that from happening, we could add this following piece of code here. So let's look at it. Let's look at this and let's actually explore this a little bit. Let's say age is equal to 25. Type age is numeric. What does it return? True. So if we set age equal to 25 with a bunch of spaces around it, now if we do is numeric, what is returned? False. So we need to do something to age to fix that. So one of the, remember that one of our string functions that allows us to be able to take away space from the left and right is called strip. So we could say age is equal to age.strip. Now, if we type out age, it's just the value of 25. So now if we say age is numeric, we get a value of true. Now, one of the things I have not tried is actually doing something like this in the shell of Thony. What happens if I do this? Okay, it actually enters age. Let's see, let me try 24. Okay, so that does work, and it does work in the shell here in Thony. I wouldn't know if that would or not. So you should be able to copy and paste these examples down here in the shell and see how they work. Here's an example to where we're using the is alpha function in Python. Now, where am I getting some of these at? Where am I getting some of these functions at? In the string notes, there are some links that you can go to, or you could just bring up a browser and type in Python 3 string functions. And let me actually type that right. Okay, here's the docs for Python. We click on this. Here's a bunch of these through here. Some of these are actually constants at the front here. And the reason why I'm bringing this up is you're going to need to learn how to read some of these documents for different programming languages. Since we're working with Python, you need to learn how to get around the documents and learn how some of these work. So I want to do this. I want to take a little bit of time to look at these. Let's see, let me go down a little bit further. Let me see if it lists these functions. I'm not seeing it right away. Let's see. Common string operations. That is not giving me what I want. So let's do this instead. Since I know one of the functions I want is numeric, let's see what pages come up for that. Okay, built-in types. Let's see if I can find. Now we could click on this and it will show us some of these. So you could go to some place like W3 schools. I was wanting to try to find this in the Python document pages. Let me try. Alpha. Built-in types. Yeah, let me do a find in the page. Is alpha. Okay, so here we go. Now, let me get my mouse back. Okay, right here. Return true if all the characters in the string are alphanumeric. So you can go through here, these standard types, string methods. There's a ton of these in here. A lot of little helper methods to help you be able to do things easily in Python. So you can go through here and look at these. They're usually in alphabetical order. Now, some of these at the beginning aren't going to make a lot of sense because they do talk about advanced topics or whatever, but it's good to go through and start getting familiar with the doc pages if you can. So here's an alphanumeric here. So you can read those if you'd like. So that's where I'm getting some of these functions at. So here, if we're going to ask somebody for their first name, we'll assume that a first name can only have characters between A and Z. This will allow us to be able to check to see that somebody did enter in a first name that seems to be valid, has letters just from A to Z. Print out their name if they did type in a valid name. If not, it'll print out an error saying that the name is not valid. We can also use, there's an index function that checks to see how many occurrences of a word is contained in a string. So here we can ask the user to enter in a string or some kind of a phrase, and it checks to see if the word is contained in that phrase. So I'll leave that to you to go through these as an exercise. Starting in Python, well, it says right here, as recent as the 3.10 version release, a new statement has been made available called the match case. A lot of programming languages have something like a switch or a match statement that allows writing some of this code where you'd have like an if else and a bunch of if else's. It allows you to be able to write the code a little bit more efficiently this way, to where you have a variable and then you specify certain values. And if that variable is equal to that value, then it executes that body. So here's an example. Let's set answer equal to the letter Y, and we check to see if we match answer here. And if answer is equal to Y, we print out yes. If answer is equal to no, we print out no. And anything else, it just prints out maybe. Now there's times to where we may want to allow uppercase and lowercase letters, or we want to be able to allow several different values to execute the same part of code. So for example, we may want to ask the user, do they want to continue running a program? And if they enter in an uppercase or lowercase y, then we want to print out yes. If the person enters in an upper or lowercase n, we want to print out no, and then anything else that they enter, we would just print out maybe. So here's some additional exercises. I'll allow you to look at those yourself, and you can try to go through those if you'd like to. And that's about it. I'll see you on the next video.